live. And here we go. Solution of a system of linear inequalities is what we're doing today. So for those of you who might be looking, hey, where's that page? It's the back of these optimization linear programming problems, which we'll do after. I think I like doing this in the order of the ones without the word problems first. So let's take a look at that. What would it mean to have both of those inequalities true at the same time? Well, they're inequalities, so of course they are zones, right? They're regions. And for both regions to be true, it has to be a region where the points satisfy both inequalities. So the first thing I'm going to do is, of course, I'm going to graph them so I can figure out what lines they are. I'll do them in two different colors here. So let's see, I'm going to go to my pens, and I'll do this one in blue. So in blue, this one will be blue, and let's see, 2x plus 8, or 2x plus y equals 8, and what happens when x is 0? When x is 0, y is 8. What happens when y is 0? When y is 0, x is 4. Always nice. When you notice that the coefficients are factors of the constant, you know that your x and y intercepts will be integers. So that's always a nice, easy way to graph things. What kind of a line is it? Solid or dotted? It's dotted, right? Because that's a less than symbol in here. So in here, less than. So it's going to be a line that is dotted that goes through 0, 8, which is right there, and 4, 0, which is right here. And it's a dotted line, so I'm going to draw a dotted, there. Okay? Okay? But which way do I shade? So let's do a test for 0. So this one is 2x plus y is less than 8. And I'm going to test my usual test point, 0, 0. So 0, 0. 0 plus 0 is less than 8. Is that a true statement? Yes, it is. So I am going to shade left. But you know what? I'm not going to do it yet, because I got to figure out where the other one gets shaded too. So I'm going to now go to a blue line here, or to a green line. So this one's going to be green. 3x minus 2y is greater than 6. Once again, I notice that 3 and 2 are both factors of 6. So I'm going to have integers for my intercepts. So when x is 0, y is negative 3. And when y is 0, x is 2. So 0, negative 3. So 0 over and 1, 2, 3 down. And 2 over and 0 up. So there we go. There's my green line. And once again, it's a dotted line. But which way do I shade? Let's test 0, 0. So 0, 0 is going to make 0 minus 0 is greater than 6. Is 0 greater than 6? False. So I am not shading 0, 0. So I'm going to shade to the right. So my answer, which I will put with this lovely highlighter here, my answer, the zone that makes this true, makes both of these true, the zone is left of the blue line and right of the green line. So left of the blue, right of the green, it's in here. So I don't know how you want to shade that. Got a pencil crayon handy? Turn your pencil sideways. Got a highlighter? You could use a highlighter. Of course, that bleeds through, then in the other side it'd be hard. So there we go. And I know I'm trying to go right up to the line, but not over it. Oh, that's pretty good. I'm pretty happy with that. And hang on, I just wiped out my. There we go. And you know, you can do a check here. Pick a point that for sure is in the zone. How about 1, 2, 3, 3, negative 2? 3, negative 2 should make both inequalities true, right? And let's see if it makes them true. So let's see. 2 times 3 is 6. 6 plus negative 2 is less than 8. That's true. 3 times 3 is 9. 9 minus negative 4 is greater than 6. True. So that point checks. And of course, if you picked a point that was, say that you picked a point in here. Actually, that's a bad idea. I shouldn't do that. Let me pick some different color here. If you picked a point in here, what would you notice? You'd notice that it would make the green line's inequality true, but it would make the blue one false. Right? Conversely, if you picked one here, you'd make the blue inequality true, but the green one would be false. And if you picked one up here, they should both be false. There's only one region where all three of them, or where, sorry, both of these inequalities is true. And there it is right there. So let's try another one like that. Any questions on how I got this one going? All right, let's try this one. Once again, we're giving you pretty easy things to graph where we can just use intercepts because the coefficients are factors of the constant. So once again, I'll do blue and green. So this guy's going to be blue. So this will be x minus 5 is less than, or x minus y is less than or equal to 5. So when x is 0, y is negative 5. And when y is 0, x is 5. So 0 over 5 down is here. And 5 over 0 up is here. But what kind of line do I want this time? Notice it's a solid line this time. Very nice. And then which side? Let's again test 0, 0. Is 0 minus 0 less than or equal to 5? It certainly is. So we're going to shade left because we have to include 0, 0. Correct? All right. Let's do green now. X plus 2y is less than 4. Well, if x was 0, y would be 2. If y was 0, x would be 4. So 0 over and, okay, what's the x-axis here? So 0 over and 2 up, and 4 over and 0 up. What kind of a line is this one? This one's dotted. Oh, that's terrible. I'm going to undo that. Start that over. There we go. Okay, and once again, I'm going to test 0, 0. And 0, 0 tells me that this would be 0 plus 0 is less than 4. So once again, that's true. 0 is less than 4. So I have to shade, again, I have to shade to the left, don't I? Right? So again, shade left. Okay, so I'm shading left of both lines. Can you kind of see which zone that is? It's this zone in here. Oh, I went over the line. It's hard to get right in there. This thing's too fat. Oh well, you get the idea. Shady, 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 shady. Okay, I won't bother running through the check, but suppose I just asked you, so pick me a point that is for sure. Pick me a point that's for sure in the zone. What would you give me? What do you got? Well, that's true. 0, 0 passed both tests, so yeah, 0, 0 is in the zone. All right, suppose I put another constraint on it. What if I needed a point where both coordinates x and y were positive? What would you give me? How about 1, 1 would work, right? That's right here. 1, 1 is right. Oh, does it work? Oh, wait a minute. Oh, does 1, 1 work? Because here's the x-axis right here, right? So there's 1, 1. It looks to me like that doesn't work, right? Because it'd be on this dotted line. So no. Are there any points where x and y are both positive? And the answer is no. It doesn't look like it, right? So I actually couldn't give you an answer where they're both positive. All right, is there any points where they're both negative? Sure, lots of them. How about over here at -1, -1? That would be a point in the zone. Okay. Now, what happens when you have lots of these lines? When you have lots of these lines, shade the untrue side instead of the true side, and then your answer will be wherever you didn't shade. So let's see. Y is greater than 1. So let me do that one here. I'll use green for that one. So what does y equals lines look like? Are they vertical or horizontal? Y equals, think about that. Horizontal. So here's y is equal to 1 right here. Y is equal to 1. So I would like to shade the part that isn't true. So I'm going to shade down here. Right? There. So the answer is still in this white part. There. That one's done. Y is less than 12. I'll stick to the green line. 15, 14, 13, 12. Which way is less than? Down. So the part up can't be the answer. So the part up above here cannot be the answer. So you are not the answer. Oh, I went over the line. Pretend I didn't go over the line. All right. X has to be greater than 3. 1, 2, 3. So that's this vertical line here. Okay, which way is greater than? To the right. So shade the part that isn't the answer. That'd be to the left. So right now, that white box is where all my answers are. But now I got a couple other things. I got x is less than 15. Well, guess what? That one kind of doesn't matter. Or does it? Oh, yeah, it does. I guess, yeah, there's a 15 here. Okay. All right, it does matter. Sorry. Let me do another black line for a vertical line. So x is less than 15, so I'm on the left of this, which means it can't be to the right. Oops. And finally, I think I'll use the coordinates, the x-intercepts technique and y-intercepts technique. When x is 0, y is 8. And when y is 0, x is 12. So 0 over 8 up, so 0 over 8, 5, 6, 7, 8 is a point. And 12, 0 is a point. And it's a solid line. Pretend I could draw that straight. You guys, of course, at home could use a ruler if you wanted to. And then which side am I doing? Let's test 0, 0. Is 0 plus 0 less than 24? It is. So 0, 0 is in the zone. But remember, how am I shading? I'm shading the things that aren't the answer right now. So that would be everybody out here. So all this white zone out here can't be my answers. You don't count. So that's it. That's my answer. So if I needed, okay, give me a point that's in the answer. How about 4, 2 is an answer? How many integer answers do I even have? Well, I guess I'd have to know for sure where this cross point was. Like, is it on, I don't know, is my drawing bad and it really is going right through, what would that be? 3, 6? Does it go right through 3, 6 on yours, or is it a little below it like mine? Is it right on it? Then 3, 6 would probably be a point. Because remember, these are all solid lines. So it can be on the lines, right? So it looks like 3, 6 is a point. 4, 2 is a point. Let's see, 3, 5 is a point. 4, 5 is a point. Let's pick ones that are kind of for sure out in the middle here. How about 5, 3 is a point, and you get the idea, etc. So this is possible solutions. And there we go. All right. I think it's time to play the your turn game. If you've got this one done, get started on the next one. See if you can get it yourself. And again, let's use reverse shading because there's 1, 2, 3, 4, 5 different zones here. Oh, hang on. Is this one exactly the same? Is the second one exactly the same as the first? Oh, then don't bother doing that. Never mind. I didn't realize that. Okay. I don't know what happened there. Okay, so that's actually it for those 2 pages, right? So let's go back now, and let's do a word problem. For the second word problem, we'll do the you play game. So here we go. We call this an optimization problem. A company makes couches and love seats. So we've got a furniture making company. We've got Palliser Furniture here. Due to constraints in the work area, no more than 10 couches or 15 love seats, that's supposed to be seats, not Sears, seats, can be made in one day. In total, no more than 20 pieces of furniture can be made in one day. Let X represent the number of couches, Y the number of love seats made in one day. The company profits $300 on couches and $400 on love seats. The company, of course, wants to do what all companies do and maximize its profits. What combination of couches and love seats should be produced? Write a system of inequalities to represent the situation. Okay, and there's 5 of them. What are the 5 inequalities? Well, okay, X is the number of couches. Here's the first one, the easy one. No more than 10 couches. So X has to be less than or equal to 10. No more than 10. I could make 10, but I couldn't make 11, right? No more than 15 love seats. So Y has to be less than or equal to 15. Now, what are my other ones? It said there's 5 of them. 2 of them are kind of not told to you, but you have to assume them. They're kind of painfully obvious. How would you go to the factory and make yourself a negative couch? Just a really ugly couch? Obviously, X has to be greater than or equal to 0. Y has to be greater than or equal to 0. So there's 2 of them right there. What's the last one? There it is. See this sentence here? What's that telling me? X plus Y, couches plus love seats, total amount of furniture made today can't be more than 20. Right? Does the logic of that make sense to you? So now, let's put all that onto here. Let me see if I can make that a little smaller. There we go. Okay. Let's start with X is less. Okay, so first of all, I guess we better count on the grid here, right? There's a lot of space here, so I think I can just count by ones. I can easily get to 15 in one direction and 20 in the other direction. I think we got lots of room. So that's going to be X, Y. You might have one where you have to count by 5s or count by 2s. So be ready for that. All right, let's graph less than or equal to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's this guy. So that's this line here, and it's a solid line. to make it straight. There we go. Okay. So 10, and oh yeah, and we're shading the area that's not the answer. So if x is less than or equal to 10, that means bigger than 10 is out. So all of this space out here is not answer. Beep, beep. Okay. Next, y has to be less than or equal to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, but it's less than, and I want to shade the part that's not the answer, so I'm kicking out the greater thans. Bye-bye, greater thans. You don't get to count. Next, greater than 0, less than, I kind of have that already, right? I didn't even graph the parts that are greater than, less than 0. Like I kind of have those already. I guess I could, just as a token, maybe put a boundary around here. Right? So you can tell that you can't make negative furniture. So there we go. That took care of the greater than zeros and less on x and y. But now I've got this equation here. X plus y is less than or equal to 20. Well, again, 20 is both the x and the y-intercept. So this is 15, right? 16, 17, 18, 19, 20. This was 10, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I am joining those 2 points. I have a slope of 1, so I'm going to try very hard to get a slope of 1. In fact, I think I might actually even count it, since I do want to be as accurate as I can be. So there is a dot there. There's a dot there. This has to be a solid line again. I can actually stop there. I don't really care what happens to it after that. And I'm shading. Okay, so I'm going to test 0, 0. 0 is less than or equal to 20. That's true. So 0, 0 counts in the answer. So again, I'm coloring out the parts that aren't the answer. So that little space there goes away. And now I have myself a zone. All of the whole numbers there, all of the numbers along these lines, all of the whole numbers, right? So all the integers, right? You're not going to make a half of a couch or a third of a love seat. So I have to count the numbers on the grid corners. And I have all of the numbers along here. I have all of the numbers along here. I have all of the numbers along here. I have all the numbers along here, all the numbers along here, and all of the numbers in the middle. How do I figure out which one gives me the best profit? Well, first of all, I have to make what's called an optimization equation. What is my profit? Well, my profit is I make $300 on every couch and $400 profit on every love seat. So whichever point along those black lines or in that white space gives you the XY coordinates to make this as big as possible, that's going to be my answer. And I have good news for you. You don't have to try them all. You know what you have to actually know is it's got to be one of the corners. And this is usually where some wise guy goes, yeah, what if they were curves? Well, then you'd have to go with what's called the critical points of the curves, and that's something you learn how to do in calculus. So here in regular high school math, pre-calculus, we'd have to stick to, for this kind of question, linear. But anyway, What are the corner points? Well, one of the corner points is 0, 15, right? That's this guy up here. 5, 15, that's this guy here. 10, 10, that's this guy here. Obviously, 0, 0 is a corner, but I think it's fairly safe to assume that would be the worst of the profit. You'd have a profit of 0. And this guy here at the bottom here is 10, 0. Now, we were able to say that when it comes to these points, I'm going to write them again. Let's eliminate the ones we know we don't have to try. Obviously, 0, 0 is not going to give you much of a profit. And think about it. As long as the x coefficient is positive, do you know what I mean by that? Which in this case, the x coefficient is 300. As long as the x coefficient is positive, is there any possible way that 0, 15 could be bigger than 5, 15? No. So don't bother trying it. And by the same logic, since the y coordinate, the y coefficient is positive, there's no possible way 10, 10 couldn't be bigger than 10, 0. So don't bother trying that one. So really, the only two that I have to try are those two. Which one gives me the most profit? So let's try them. My profit is 300. I'll try the 515 first. If I made 5 couches and 15 love seats, I would get 300 times 10 plus 400 times 15. So that's 3,000 plus 4,500, which is 7,500. Or let's try the other one. Let's try 10, 10. Maybe that gives me the best profit. So that'd be 300 times 10, and I think you can see right away, wait a minute. I don't know why I put 10 there because I goofed that up. Can you fix that? Sorry. I don't know. Why didn't you stop me? Let's try that again. 300 times 5. I think I had the right answer though, didn't I? Yeah, I did. So in other words, I just ignored the numbers I actually wrote down and just did the calculation in my head properly. Oops. There we go. I had that part right. It is 7,500. Anyway, what if I use the point 10, 10? That's 300 times 10 plus 400 times 10. And that's actually going to be 3,000 plus 4,000 is 7,000. So, therefore, I get a maximum profit if we make 300 couches and 400. Oh, sorry. No, that's the profit numbers. That's the amount of money. Get that out of here. If we make 5 couches and 15 love seats per day. Thank you. You'd think 10 and 10 would probably beat it, but no, because the profit margin on the love seats is higher, you're better off making the 5 and 15. And that's what you call a linear optimization problem. This is the kind of math you get an actuary to do for you if you were trying to set your prices. We've seen maximum profit before in quadratics, but we only had one variable to work with, right? So that's why it gave us a quadratic. We saw that in the R5 unit, and that was complicated enough, right? Because remember, you could change 2 different things, but you change them in terms of the same variable. Here, you actually just have 2 different variables, couches and love seats. If this were to become a quadratic situation, you'd need to figure out things like critical points and stuff, and yeah, that's a little beyond pre-cal. That's into cal. So, want to try the next one? All right, why don't you guys give it a shot? First of all, I'll give you a minute, see if you can come up with your system of inequalities. We're missing some people at home today. I hope that they catch up on this video. Okay, so guys at home and guys in the room, see if you can make those equations. I'm going to do attendance while we do that. Let's see. students in the class. Oh, except one. We have one person away, but they've already phoned to excuse us. There we go. Okay, back to my... All right. Let's see if I can catch up to you. So, we have... once again, there's 5 inequalities here. Let's start with the easy ones. Obviously, x is going to equal, let's see. Let x equal, I guess I should say what's what. I'm going to say let x equal number of snakes. And y equal, what's the other one? Lizards? Lizards. And I'm going to change one of the words in the equation too. Can you change the word profit? Guess what word I'm going to use instead of profit? I'm going to use the word revenue. Anybody know why I made that change? Because it just tells me how much they sell for. It doesn't tell me how much my profit is on them. Right? Suppose I sell the lizards for $12, but it cost me $10 just to put them in my store. Meanwhile, the snakes, you go to the garden and grab a snake. So they cost me like $2 to put in the store, but I sell them for $15. Well, that's a very different profit equation. So this is just a revenue equation, not a profit equation. That's a mistake. And I'm going to say x is snakes and y is lizards. So obviously the obvious equations are you can't sell me negative snakes or negative lizards. So obviously we are in the positives. And then no more than 13 reptiles can be held in total. So that's x plus y has to be less than or equal to 15. Oh, 13, sorry, 13. And the owner would like to keep at least, so the owner would like there to be at least 5 snakes and at least 4 lizards. Are those the 5 equations that you got? Question?
Why do you need the greater than 0 if you have the greater than 5 and greater than 4?
That's a good point. Obviously, in this case, this equation here kind of overrides that one. But it is still important when you're setting up your problem to make sure you understand all of the parameters. You're right, though. When it comes to actually graphing it, they're not going to matter. Those 0 equations, I mean, aren't going to matter. All right, I think I'm ready to start graphing. Bigger than or equal to 5. So 1, 2, 3, 4, 5. So that's right there. But it has to be bigger than, right? So bigger than. So first draw me the line. Try to be a bit straighter than mine. Try to be a bit straighter than mine. So if it's bigger, that means that the ones that are smaller don't count. So again, I'm wiping out the ones that are okay. And again, you know what? I shouldn't have stopped there because again, you can't be there, right? And y is bigger than or equal to 4. So 1, 2, 3, 4. And maybe I should have counted by 2s so that I'm not so small, but oh well, you get the idea. You could do that yourself if you wanted. And it has to be bigger than 4, so all the numbers smaller than 4 don't count. So, and again, the negatives don't count. So there we go. And then x plus y is less than or equal to 13. So I'm going to go up to, this was, what was this number? This was 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13. This was 5, 6, 7, 8, 9, 10, 11, 12, 13. And I think, once again, I want to be accurate here. So I'm going to go and use the slope of 1. Count 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, 1 over, 1 down. And there we go. I have a dot there and a dot there. And I feel like I changed directions a little bit there. But That's because I have a hard time seeing these. It's kind of small. Let's see. Let's see, did we change? Oh, jeez. Oh, come back. One over, one down, one over, one down, one over, one down, one over, one down, one over, one down. Nope. I just got off my line a little bit, that's all. So there we go, so there we go. And let's shade. So everything, it has to be, okay, so I guess I should do a test point first, right? So let's test 0, 0. So 0 plus 0 has to be less than or equal to 13, which is true. So 0, 0 is in the inequality zone. So that means I'm going to shade, and I'm going to misspell the word shade. I've got shale. I'm going to shade right because I don't want 0 in the shaded zone. I want the answer to be the part that isn't shaded. So there we go. So we're going to shade everybody to the right. Okay, so that's it. So what's my optimization equation? Well, my revenue is equal to $12 per snake. No, I've got that backwards. Isn't it $15 per snake and $12 per lizard? Okay. What are my corner points? All right, well, let's see. What are my corner points? Looks like one of them is 5, 8. One of them is 5, 4. And the other one is 9, 4. Okay, so if the coefficients here are positive, there's no way 5, 4 could beat 5, 8. And I could have looked at it the other way. There's no way 9, 4 could have lost to 5, 4. So that one isn't even worth trying. But I honestly don't know, just looking at it. 15 times 5, 12 times 8, or 15 times 9, 12 times 4. What's bigger? Let's check. So my revenue, if I have 0.58, would be 5 15s plus 8 12s. That's $171. My revenue, if I had 9 X's and 4 Y's, would be not by a lot, but 183. Therefore, I should use 9 snakes, or I should keep 9 snakes and 4 lizards in stock to maximize my potential revenue. And that's it for optimization questions. That's the lesson. And I'll pick a couple of these from the workbook for you to try. And then that's all that we're assigning. So I'll stop the lesson because the lesson's over, or I mean the video of the lesson. And then does anybody have any questions so far in the workbook or the notes package pages that you wanted to ask about? Okay, so let me stop the lesson.